Okay, so hello everyone. Today we'll see one of the most frequently asked interview problem, which is sort an array of zeros, ones, and twos. So let's see what does the problem says. It says given an array of size n containing only zeros, ones, and twos, we have to sort the array in ascending order. Let's understand this with the help of given example. We are given the size of the array n is equal to 5, and we are given the array elements as 0 2 1 2 0. So after sorting the array in ascending order, we have to output this array elements as 0 0 1 2 2. Now, let's see the second example which is given here. N is equal to 3. Array elements are 0 1 0. After sorting this, we have to print the array elements as 0 0 1. Okay, so one more constraint given here is the expected time complexity should be big O of n, and expected space complexity should be big O of 1. And one thing we also keep in mind, we have to sort the array in place. In place means we have to modify the given array only, which is given here. We don't have to return another element after sorting this given array. Okay. Okay, so let's understand this with the help of example and understand the approaches also. So we will discuss the first approach here. First approach can be the like normal counting approach. So in this approach, what we'll do is that we'll just count the zeros, ones, and twos, maintain one count variables. So let's see this with the help of given example. The given array is 0, 1, 2, 0, 1. The count of zeros is 2, count of 1 is 2, count of 2 is 1. Okay. So after finding out the count of zeros, 1 and 2, what we'll do is basically we will put the number of zeros, 1 and 2 as per their counts in given array. And the array order of elements will be we will first put zeros, then ones, then in the last twos as per their respective counts. So now we have find out the count of 0 1 and 2. The output array will look like the size of the array was 5. Count of zeros was 2, so we'll put zeros first. Count of 1 was 2, so we'll put 1, and then in the last we'll put 2. So that is the output, required output. So this is the first approach. So this is the normal counting approach, but here we are doing the array traversal two times. One for counting number of zeros, ones, and two, and then putting the number of zeros, one and two according to their counts in the array. Can we think better than this approach? See the better approach. In the better approach, we can try that in the earlier approach, we were traversing the array two times. Can we think like we just have to traverse the array only one time? So, to think in that way, we have to just look at the output of an example like 0 0 1 1 2. Here we are seeing that zeros are occurring in the left part of the array, ones are in the middle part, and twos are in the right part. So what we'll do is that we will maintain three pointers in the array: left, mid, right. Left will be pointing to the leftmost array index. If the array is 0 index, then left will be 0. Mid will be pointing to the first like leftmost element itself, because we will traverse the array by using the middle pointer only. So mid will also be initialized as 0, and the right most pointer will point to the right most index of the array, which is the size of array minus 1. So here size of array is 5, so right will be 4. Okay, so we will traverse the array using mid pointer while it is less than equals to the rightmost pointer. While mid less than equals to right, if we are encountering 0 as the mid element, what we'll do is that we'll just swap with the leftmost array element. Actually, we saw earlier, we discussed earlier that we have to put the zeros in the leftmost part of the array. So what we will do, we just swap array of mid with array of left, and we'll just increment the mid pointer and left pointer. Else, if array of mid is 1, अगर middle element 1 है, so we'll just increment the mid pointer, because mid, like 1 we have to put in the middle position itself, so we don't have to swap it with the left or right pointer element. So we'll just swap it. Else, like in the last else case, we are encountering that case when the middle element is 2. So when it is 2, we have to put that element in the rightmost part of the array. So what we'll do is that we will swap array of mid with array of right, and we'll just decrement the right pointer. Okay, so let's try run this approach with the help of an example. Like it is 0 1 2 0. These are the indexes. Okay, so first left will be initialized as 0, mid will be initialized as 0, right will be as size of array minus 1, which is 3. uh, as mid is less than equals to right, because 0 is less than equals to 3, and array of mid is 0, because mid is 0 and the first element is 0. So in that case, we just have to swap with the leftmost element, which is left, which is pointing to 0 itself. So swap array of 0 with array of 0 only, and we will just increment the left pointer and mid pointer. Now left is 0, left is, sorry, 1, mid is 1, and right is 3. Okay, now we'll just again compare. If mid is less than equals to right, 1 is less than equals to 3, which is true, and array of mid, which means array of 1, array of 1 is 1. So in that case, as we discussed above, when the array element is 1, we just increment the middle pointer. So mid will be equals to 2. Okay, in the next iteration, left is 1, mid is 2, right is 3. We'll again compare. If mid is less than equals to right, 2 is less than equals to 3, which is correct. Array of mid, which is array of 2, is equals to 2. So in that case, what we have to do is to swap with the rightmost element, is the third case. Okay, so we will swap array of 2 with array of 3. So up till this point the array is 0 1 2 0. Now after doing this operation, our array will include 0 1. We have to swap these elements. Sorry, we have to swap, yes, 0, it will be 2, it will be 0, and our left was 1, so this is the left, right was 3, this is was the mid, and right was 3. Now after swapping this, what we have to do, we have to just decrement the right pointer. Now right will equals to 2. Okay, now we'll again compare. If mid less than, let's see what the current value of pointers. Now left is 1, mid is 2, and right is also 2. If we compare, if mid is less than equals to right, so this is true, 2 is less than equals to 2. So and now we will see what our current array element pointing at the mid index, which is 2. Mid is 2. Oh, here actually here we have swapped the element, so here it is 2 and here it is 0 at the second index, and the third index it is 2 when we have swapped. So array of mid is 2 0, sorry 0. So in that case what we'll do is that we'll swap with the leftmost element. So we'll swap array of left with array of mid, and then we will increment the left pointer and mid pointer too. So let's see, now our array will become, previously it was 0 1 0 2. Now after swapping the left and mid pointers, it will be 0 0 1 2. Okay, now our left pointer value is, it was 1 and we incremented, now left is 2, mid is, previously it was 2, now mid is 3, and right is 2. Now as middle pointer is not less than equals to right pointer, so our iteration will stop here. Okay, so this is our sorted array final output, and we have seen that it is the required output. Okay, so now Now we will see that what was the time complexity. Here we are traversing the array only once. We are traversing only once, and we are doing the in place modification of the array only, and the space complexity is also a big of 1 because we are using just pointers variables to maintain the mid, left and right indices. Okay, now let's come to the coding part. Okay, so we have discussed the approach. Now we will see the coding section. So as we discussed, we will maintain 3 pointers, which is left, right, and mid. Left will be initialized as 0. Right will be size of array minus 1. Size of array is given as n, so it will be n minus 1. And mid will be 0. Now we will traverse while left less than equals to right. Sorry, mid less than equals to right. If array of mid is equal to 0, we will do is that swap the array mid element with the leftmost element, and we'll just increment the mid counter and left counter. Second case is if else if array of mid is equal to 1, we'll just increment the middle pointer. Else, this is the case when array of mid is 2, so we will just swap the array of mid element with the right element, and we'll just decrement the right pointer. Okay. Let's define one swap function also. Let's swap temp variable will store the array of I. Now array of I will get assigned of array of j element, and array of j will be equals to temp. Okay. Let's see this code is working. Like for n is equal to 5, and this is the output and this is the expected output, which is matching. Let's submit this code. Okay, so it is successfully submitted. So we discussed the two approaches earlier and we implemented the better approach here. That's it. Guys, if you like this content and if you found this video informative, please like, subscribe and share it with your friends. Thank you very much.